So if we're borrowing 1 from this 7, this changes to a 6, but we're really borrowing 10. So the 1's column becomes 10 plus 3, or 13, as we showed using this notation here.
Now if I go to the numerator and increase this, it's going to change the number of pieces that are shaded. So there's 1/4, 2/4, 3/4.
Now if we press graph, it'll show the line on the scatter plot, and we can see that the line is an excellent model for the given data. Let's go ahead and answer some questions now.
One way to illustrate this would be to use a conveyor belt where we have an initial input, let's say 3, and it becomes the input into F, where F squares its input and produces an output of 9, and this output becomes the input into G. So we multiply 2 times 9, and the final output of this composite function would be 18.
Because we know the height of the triangle, there are two smaller right triangles formed. There's this right triangle here on the left, and there's the right triangle on the right.
Again, the red line is the tangent line. Now the important part here is the slope of this tangent line will represent the instantaneous rate of change of the function at that single point. Let's take a look at this problem in another way. This is the area that we actually want to find under our function. What we're doing is using rectangles to approximate the area under the graph. As we increase the number of rectangles, you can see our approximation gets better and better. And you can get the idea, if n went to infinity, it actually would approach the area under the function.
We have -8 pi. So this tells us that the net rotation would be opposite of the orientation. So in this case it looks like it should be clockwise. Let's go ahead and look. It does look like the way this vector field is oriented, the net rotation would be clockwise in this direction.
It's hard for me to believe sometimes, but I just finished my 15th year teaching. I taught 1 year at the middle school level, 5 years at the high school level, and I just finished my 9th year teaching at the community college level. Before teaching, I actually worked in business for almost 4 years, but I haven't once regretted the change. I look forward to many more years teaching mathematics. I started making math videos about 2 years ago because I wanted to create a resource for students that would be available any time of day for students to learn. Since the videos can be paused or watched over and over again, I found that for many students it reduced their math anxiety. For my online math classes, it's the main way that I teach the concepts and answer student questions. For my face-to-face students, I've been able to assign them for homework, which allows more class time to be used for more active learning and problem-solving activities. They're also a great asset for students that may miss class or need some extra help. And I've also been able to integrate them into reviews where I embed the links of the videos right on the review. All of my videos can be accessed through my YouTube channel, my website, or my blog, which I'll show you briefly right now.
Here's my YouTube channel where I host all the videos. You're probably already familiar with YouTube, so I won't spend too much time here, but I will put a link here on the screen for this channel. Here's my Mathispower4u.com website. You can see across the top I list the different courses that I've made videos for. On the home page I also have links here to open source textbooks for arithmetic, beginning algebra, and trigonometry, which I've used in the classroom. I also have many of the videos on teachertube.com. So if you click on a specific course, let's say algebra, you'll see all the major topics listed, and then below all the videos that apply to that topic by objective. These are all active links. You can just click on them and the video will play. So this website's pretty straightforward. I do have quite a few videos, so sometimes it does take a little bit of time to find the right one, but they are all here. Now that I have mini lessons for most major topics, I am in the process of creating example-only videos. If you notice under trigonometry, on the left side I have all of the mini lessons, and on the right side I have example-only videos that are much shorter. And I hope to do the same for the other courses as well. The last way you can access the videos would be to visit my blog. There's a link here from the home page. And the blog is nice because you can search for a specific topic and the relevant videos will appear on the screen. So for example, if we type in derivative, all of the videos that relate to derivatives will appear on the screen, and then you can view the appropriate video. Search by course here on the right, and I've also included several other excellent math resources down at the bottom that you can link to from this blog.
I do want to continue making more and more videos to cover more topics, as well as go back and refine some of the videos that I've already recorded. But in the bigger picture, I hope to help create quality math instructional tools that would be available to anyone at any time. I'm currently integrating my videos with open source textbooks and an open source online math assessment and course management tool called WAMAP. So I'd like to finish by showing you the trigonometry course that I'm currently developing.
You can see here there are 6 chapters. If we open up a chapter, we'll see this section, so it's organized very much like a textbook. And then within each section, you can see the first link is to the open source textbook. So if we click here, students can open up the textbook and print if needed. Then we have the objectives, followed by the video lessons. And again, these are the videos that I've made hosted on YouTube. And the last step is for students to get practice, so here's the homework. And then there's ways for students to get help within each question. If after reading the question they need some help, there's usually a video example of a problem that's very similar to the given problem. Or if they wish, they can also access a textbook within each homework question. So what I've tried to do here is combine my video tutorials with an open source textbook and now an open source course management system with instant feedback and help for students. So students can read a textbook, watch video lessons, and get interactive practice all in one place. And I hope to add more courses soon.
If you have any questions, comments, or have any desire to contribute to a project similar to this, please let me know. Thank you.